Hello and welcome to this video lesson about variables. The first thing we're going to cover is what exactly is a variable. So a variable, well, if I ask you this question, you might say x, because that is the variable that students often see when they're in pre-algebra or algebra. However, variable doesn't necessarily have to be the letter x. It can be any letter or symbol that represents some unknown quantity. Okay? So for example, we can use the letter x. We can also use other letters such as M or N. We can even use symbols like a smiley face or a random scribble. Right? It doesn't really matter. Often we use letters, but it can be anything that represents some value we don't know yet. So let's look at an example. In arithmetic, we're used to dealing with problems where, for example, we have you and your 4 friends win a $1,000 jackpot. And you want to know how much money each person gets. Well, we know that you won $1,000 and there are, so you plus your 4 friends. So we're going to divide this $1,000 amongst 5 people, and we would get that each person receives $200. Now in algebra, a problem you might encounter is that you and your friends win some jackpot. And you want to know how much money each person gets. Well, you don't know the amount of money in the jackpot, but you can represent it with a variable. So we don't know the jackpot, but we can represent it with the letter J. Okay? So whatever the jackpot is, it is represented by the letter J. So if the jackpot is $1,000, in this case, in the arithmetic problem, J was equal to 1,000. Now in this problem, this example I just gave you, we don't know what it is, so we're going to leave it as J. So variable representing the jackpot. Now you can still work with this variable. Even though you don't know its exact value, you can still do operations with it. You can do all sorts of things with it, including we know that if we have the jackpot and we're splitting it up amongst people, we can divide it by 5. Okay? So each person gets 1/5 of the jackpot per person. Even though we don't know what that exact jackpot is, we know that each person gets 1/5 of it. Okay? So this is useful for more complicated problems where you have some variable that, or you have some value that you don't know, and you can represent it with this variable. So let's do an example of a problem that would need the use of a variable. A box of toothpicks was spilled. 167 toothpicks were on the floor and 33 were left in the box. How many toothpicks were originally in the box? Now, whenever you're given a problem, you want to keep tab of the information that's given to you and the information that you ultimately want to end up with. So two pieces of information are given to you. There was a box of toothpicks and it was spilled. 167 toothpicks were on the floor. And there are 33 left in the box. What you want is how many toothpicks originally, so the number of toothpicks you started with. Now, this is your unknown information. And because you have some unknown value, you can represent it with a variable. And you can really choose whatever variable you want. I'm going to go ahead and use the variable t to represent toothpicks, but you can use whatever. You can use x if that's what you're comfortable with, right? But I'm going to use t. So I had some number of toothpicks. I don't know how much, but then I spilled them. And I ended up with 33 left in the box after I spilled 167. So when you're setting up your equation with your variable, you want to be aware of what's going on and use the correct operations. So I spilled some. Some fell out of my box. They're gone. So when there's a taking away, we are going to use subtraction. Okay. Whatever I originally had, I spilled 167, and I'm only left with 33. Okay. So your equation has to align with your word problem. The operations you're using, the way you set up your equal sign, your variable, they have to align with what's going on in the problem. And this comes with practice. So the more you practice translating word problems into algebraic problems and vice versa, then you get a better feel for how you should set up your equations. So in this case, I don't know what t is. If you're not familiar with solving one-step equations yet, there are multiple strategies you can use to figure out what the original number was. One way so strategy number one is you can guess and check, right? You don't know how much was in the original box, or was originally in the box, but you could guess. Let's say you're thinking, oh, well, I know that when I take away 167, I'm going to have 33 left. So I'm going to guess that there were 200 first, 200 in the box. So in order for your guess, so this is your guess, to be correct, when I take away 167, I should have 33 left. So let's see if that's true. 200 minus 167. Indeed, I have 33 left in the box. So that's one way to do it. If you're not sure how to solve one-step equations yet. Another way to solve this is to use logic, right? Use logic. Well, you know that whatever was originally in the box, when I took away 167, I had 33 left. So logically, my total is what was spilled plus the 33 that was left in the box, right? it's just if I put the toothpicks that I spilled back into the box, I'd have what I had originally. So I can just add 167 plus 33. And indeed, I would get 200. Either way, right, you get the same answer. 200 toothpicks were in the box originally. In the next video, I will go over how to solve a one-step equation. But if you're not sure how to do that yet, these are both legitimate ways to solve for your unknown variable, to just plug in some value and guess and see if it's correct, or check and see if your guess is correct. And then you could also use logic. Well, I spilled 167 toothpicks. I have 33 left. So what I had originally were the two totals added together. So this is, you know, I just want you to get a feel for how to set up your equations or how to use your variable to figure out what exactly is going on in the problem first in this video. So now I'm going to give you a practice problem, and I want you to try and see if you can set up an equation using the information in the problem. So try this problem on your own. Shara spent $105 on school supplies for her kids, consisting of 3 backpacks and 15 notebooks. Notebooks cost $2 each. How much did each backpack cost? Now, you may be thinking, whoa, this is a little complicated. This is a little more difficult than the problem we had in the previous example. But I want you to try your very best on this problem by yourself first. Try the two different strategies we had, checking and guessing and checking, and or using logic. And then, you know, if it helps you to draw a diagram, draw a picture, you can do whatever you need to do, but try this on your own first. Then in the next video, variables part 2, I will go over the solution to this problem and then a more algorithmic method on how to actually solve these equations where you have a missing variable. So try this out first, and I'll see you in the next video.